coming to this workshop, and it will be led by Dr. Tanya Rogers, and I have the pleasure of introducing her. She originally grew up in the Bay Area and then got her Bachelor of Science in Biology from the University of Puget Sound and a PhD in Ecology, Evolution, and Marine Biology from Northeastern University. She did her postdoc at the NIMS lab here in Santa Cruz and has now been hired as a research fish biologist for NIMS. And her research is focused on population and community dynamics and biogeography. And in addition to science, she's always been interested in art, and that's what brings her here today to share some of her knowledge of art and design in science communication and outreach. So go ahead, Tanya.
Great, thanks, Anne, for that introduction. So as she mentioned, I have I've been interested in using art and design for science and research communication for some time. It's mostly self-taught, though I did take a very useful digital science illustration course at CSU Monterey Bay. It was a 2-week course a few years ago, which was really helpful. So this presentation is some tips and advice and demonstrations of how do you create graphics for your research or for communicating your science that I put together, and people in the past have found it useful, and so hopefully you guys will as well. So the things that we'll be talking about, first is how to create publication quality figures, and this includes being able to interpret and follow publisher guidelines, which mostly comes down to understanding different file formats. I'll talk a little bit about exporting figures from R, and then how to make post-export edits to those figures that aren't possible to do in R. And that things for publications and presentations, including conceptual diagrams, graphical abstracts, which are now required by a number of publishers, as well as custom clip art that you can use to create those diagrams or graphical abstracts or include in your figures. And so I'll do this PowerPoint presentation first, and then afterwards I have a few demonstrations about how to do some of these things in a different software program. So that's the fun part, which we'll get to. So to start off with the basics, there are basically 2 main ways that 2D images can be represented on your computer, which are raster and vector. And if you've ever used GIS software, you'll probably be familiar with these terms already because it's basically exactly analogous, just minus the coordinate reference system. So a raster image is represented as a grid of pixels where each pixel has a color. The dimensions of a raster are given either in pixels, which is the native unit, or in terms of some physical dimensions, and a resolution or a DPI, which is digital pixels per inch. Of course, if you multiply inches times DPI, you get pixels. As I'm sure you've all experienced, a raster will look pixelated when the resolution is lower than the resolution of whatever is displaying that image. So that's usually your screen, but it could be something else like a printer. Any image can be represented as a raster, and this is always the format that's used for digital photographs. And typically when you're submitting a manuscript, you will include the figures as rasters at the end of your Word document. So a little bit more about rasters. The biggest issue you'll run into is with file size. So question you should always be asking yourself is my raster bigger than it needs to be? So first checking, is the size and resolution appropriate? So you should know that the highest resolution that most printers can print is 200 DPI, and most publishers will actually specify a DPI that they would like, as well as preferred dimensions. Usually it's around 300. So using anything higher than that, like 800 or 1200, is generally just a waste of space in your computer and like other people's email inboxes. So it's best to make it as large as it needs to be, but not hugely larger. The next thing you should look at is whether you should be using a compression algorithm, which really gets down to which file type you should be saving it as. So there are 2 types of compression algorithms, which are lossy and non-lossy. So the lossy compression, as the name implies, it loses information when the file is compressed and saved. So JPEG is a common lossy compression format that's used. This is usually what's used for full color photographs where this loss usually isn't noticeable and which would otherwise just be way too giant files. The non-lossy compression isn't as effective as reducing file size, but it doesn't lose fidelity. So this is preferably what you want to use for diagrams, figures, and other images with a small number of colors, where it's very important to maintain like sharp edges and uniform blocks of color because these are compromised when you use lossy compression. So down below here are two zoomed in circles from an R plot. One was saved as JPEG on the left, the other saved as a PNG, which is a non-lossy format. You can see in the JPEG that it gets this sort of gray halo around it, which you don't want, whereas in PNG, the black stays black, the white stays white, and there's no sort of loss of information or skewing of colors that happens. Okay, a little more raster file type. So JPEG is, as I just mentioned, is the lossy format. You want to use it for full color photos only, or things that are like full color photos, like this migratory fishes diagram down here. Is a pretty big image, has a lot of different color gradients. That one I saved as a JPEG. PNG is non-lossy format, so it's a very good choice for diagrams, figures, and other simple drawings. It's usually my go-to thing that I save as. And it's highly compatible with lots of different programs. It's another good reason to use it, as well as websites. And it allows for transparency, which is something sometimes called the alpha channel. So the striped bars here, which have transparent backgrounds, those are saved as PNG files. The TIFF is another flexible file format, usually with a lot of different options. It can be saved as uncompressed or compressed, and if you compress it, you should probably use this LZW compression that's a non-lossy format. It usually works all right. Downside of TIFFs is they can't be displayed on websites if that's something you care about. The BMP bitmap is another non-lossy format, although I don't usually see it get used much nowadays. All right.
Hey,
Moving
Tanya.
on to the second way to, yes.
I was just wondering if you could minimize the picture of, it has my picture in the corner for everybody. If you could minimize it. Somebody asked her. There, perfect. Oh, nope.
Now I've lost my presentation. I don't really know what it looks like on your end, so.
Oh, there you go. That's perfect. Thanks. Sorry for interrupting.
So, no problem. So, second way to represent image on your computer is with the vector format. So this, instead of being a grid of points, it saves the image as a list of elements and their coordinates on the XY plane. So these elements are things like lines, shapes, text, and it stores the location as well as any associated attributes. So things like their color, line thickness, font, and these sorts of things. The advantage of having a vector drawing is that vectors never look pixelated. They basically have an infinite resolution, which is because as you zoom in, the computer can basically redraw the drawing to match whatever the resolution is of your display. So this makes them very popular for things like logos, which are going to look equally crisp whether they're on a business card or on a billboard. And so this is also what you want to use ideally for diagrams, simple drawings, and then in the publication process, usually after your manuscript is accepted and the publisher is asking for the final files, they'll request them as vector images. So these are your graphs and your diagrams. And usually they're sort of individual vector files that they'll want. Great thing about vector formats, they're often very small. You don't need any sort of compression. SVG and EPS are kind of generic vector file formats that you'll see. PDF is vector file format, which can also include a mixture of raster and vector elements, as well as multiple pages. Adobe Illustrator, or the AI is the native Adobe Illustrator file type. And then PowerPoint is actually a kind of vector graphics program too. So some examples below, the Fisheries Collaborative Program logo I created in a vector graphics program that I'll demonstrate later. This is originally an SVG, which I exported as a PNG to put into this PowerPoint and to submit. The leaves are another vector drawing. And then the sea urchin here actually made in PowerPoint using PowerPoint shapes, which I'll show you later how I did that. Okay, moving on quickly to how to export files, or I guess graphics, from R properly. So there are a variety of functions that will export your plot in various different formats, and the function name is just the name of the format you want to save it as, so PNG to PDF. The first argument is the file name, and the extension on the file name needs to be there, and it needs to match the name of the function, otherwise you're not going to be able to open it later. You want to specify the height and the width in whatever units you'd like, and then you can also specify the resolution. So it's in DPI, so this is 300. You run this line, you then run the code for your plot, nothing will appear, that's normal, and then you run dev off, and then it'll save the plot to your current working directory or wherever you've specified in the file path. So as you can see, for the different file formats sometimes have different options. So the TIFF format, you can specify this LZW compression as another argument. The PDF, you don't have to specify a resolution because PDFs are vectors, so it doesn't have a resolution. If you make your plot in ggplot, you can use the, keep moving my mouse, the export methods that are outlined above, and just put your ggplot code where it says plot for code. Or you have the second option of using the ggsave function, which you run after your code, which is just the file name, and the extension automatically tells it which format you save it as, and you specify a height and width. And conveniently, ggsave defaults for rasters to 300 dpi, so it's already nice and convenient. The base functions up here default to 72, which is not very good, so often you have to specify higher resolution there. And of course, if you want to maximize reproducibility, you should try and make all the edits you can to your figures in R before moving to some sort of external editing software. But if you get to the point like towards the end of your process and there's like some changes you want to make that are either impossible or too annoying to do in R, you can do them externally, and I'll show you how to do that later. So when it comes to editing, so when you edit your figures that you've exported, or you want to create diagrams, you should always try and create these as vectors and not rasters. The reason being that you can always convert a vector to a raster, but not always vice versa. So if you need both formats, it's much easier to have it originally in vector and then export it. Also, vectors conveniently can include embedded rasters, but not vice versa. So that's another thing to think about. As far as software goes, Adobe Illustrator is best, as far as I can tell, the best vector software out there for editing. It has the most features of flexibility. Downside is it costs money. If you don't have Illustrator or your license is expired like me, you can use this free program called Inkscape, which is almost as good as Adobe Illustrator, and it's pretty intuitive to use, and I like it a lot, and that's what I'll be demoing in later. Microsoft PowerPoint is actually another option, so it's not really great for editing figures, but if you can do some kind of vector drawing in it like in Inkscape. And in the cases where you're making a diagram that's like just boxes, text, and arrows, it might even be better to use PowerPoint than the other types of software. So there's that. For editing rasters, Adobe Photoshop is kind of the canonical raster editing program. Lots of features, but costs money. If you want a free version, you can use GIMP, which is tries to emulate Photoshop in many ways. It does have a lot of different features. It's a little more annoying to use, but you can get pretty much all the things. You can do pretty much all the basic tasks that you can do in Photoshop with GIMP. Microsoft Paint, I don't think I've opened it in years, but technically that's also a raster program. Right, so a little bit about diagrams. So I think of diagrams as simplified visual representations of some sort of concept or concepts or relationships that you're trying to convey. And making diagrams, it's useful not only for your readers and for communicating those ideas, but just the act of creating one can help to clarify and organize your thinking about a problem and how you want to present it in, say, your paper or your presentation. And so diagrams, they can contain a mix of hand-drawn elements or computer-drawn elements and/or text. These are just some examples below. So the one on the left is diagram of relationships between species in the marsh. And this one was mostly hand-drawn, scanned, and then kind of cleaned up and arranged on the computer, added the text on the computer. The crab, or the fiddler crab here, I only drew one crab and then just used the computer to duplicate it, flip it around to make it smaller. So just reducing the amount of effort and time it takes to make these. The one on the right is a more involved kind of artsy diagram that I'm working on that's depicting effects of the marine heat wave on the red sea urchin fishery. And so this one actually made in PowerPoint, and most of the elements in here are PowerPoint vector shapes. So the background, water, sky, rocks, the kelp, the buildings, and the dock and boat, those are all created in PowerPoint. It does have some embedded PNG files, so like raster files in there too. So the sea star and the people are just little rasters that are stuck in there. Of course, diagrams don't have to be super artsy and contain lots of pictures. Just there's some simpler ones that I've made. So the one's left, top left here is a diagram of different types of predation risk effects that I did for Pecor and colleagues for their paper. And just the sort of process of putting this figure together and kind of organizing the relationship between these different effects, actually it helped them think about how they wanted to structure their case studies and sort of kind of structure their paper, and it helped identify some like errors in how things were classified. So just an example of how just making the diagram can help you clarify your thinking. The one on the bottom is just a diagram or visual representation of a model instead of using equations. So this is something I like to do in presentations and sometimes in publications, because models or equations can be off-putting for some people, but if you can display it as a diagram, it's often a little more accessible to folks. And the top one, the top right, is kind of a more simple diagram of consumptive and non-consumptive effects that has 3 different drawings in it. All right, so graphical abstracts. So these are basically just diagrams of your paper, and a lot of publishers are starting to require them. Usually it's after the manuscript has been accepted or right when the manuscript is accepted, they will ask for one, and often they don't give you very much time, as in like 3 days. Please give us a graphical abstract of your paper, which probably explains why a lot of them aren't very good. So if you are submitting your paper to a journal that will ask for a graphical abstract, it'll be in the author guidelines, as well as you'll see other papers have them. It's something you should be thinking about in advance, if not making in advance, in anticipation of this. The best advice I can give about making a good graphical abstract is to look at examples, because for papers that you haven't read, because you should be able to understand what the paper is mostly about without having to read the paper. You should just be able to understand it by looking at graphical abstract. And so it won't take you very long or have very much time of looking at these to realize that a lot of them are not very good. And it's very hard to tell what the paper is about just from the abstract. But there are some, gems out there, and those are the ones you want to try and emulate as opposed to the bad ones. So just kind of cartoon representation of your results, highlight the take-home messages. Don't use like acronyms or jargon or really tiny font. It should be relatively simple. So this is one I made for Brian Wells, which is, you can clearly see, this is about how different upwelling regimes affect distribution of bird predation and abundance and distribution of marine fishes. And the kind of take-home message is highlighted down in the sort of bottom right corner. And no, I don't mean to pick on Brian Wells, but this was Brian's first draft of his graphical abstract, which technically contains the same information as the picture on the left, but not as immediately intuitive to people who aren't familiar with this study already. So think more National Geographic and less like cubism. So This is a graphical abstract that I made for one of my most recent papers in ecology letters. So it just has the methods kind of on the left, and then the two main results on the right. And then the take-home messages are kind of in the yellow italic font. All right, so custom clip art. So custom clip art is easier to make than you think, and it's useful for any of the applications that I just talked about. And there's a variety of different ways you can go about it. So this is a photograph of an almaco jack that I took when I was on a cruise on the East Coast. And so this is, of course, is a raster JPEG from my phone. And you can do a few things with this. So you could decide to keep this in raster and then use a raster editing program to delete the background and save it as PNG with transparency. And now you just have a photograph of a fish with no background. Another option is you can put this into a vector editing program, and we can create kind of an outline of this fish in vector, and I can show you. I will have a demonstration of how to do that. And so now I have this nice black and white fish, and from there we can then do a bunch of stuff with it. We can just fill in all the middle with black and make it a silhouette. We can add some color and color gradients to it to make a vector color version of this fish. And now you have all these different versions available to you that you can use for different purposes. Here's a couple other examples. So the mud crab, this one started out actually as a scan of a line drawing that I did. And then I used the computer to clean it up a little bit and then to add some vector color to it. The one on the bottom here is a slightly different version of the mud crab. And then here I actually painted it in Photoshop, so the raster program. And you can get kind of a different effect if you color something using a raster program versus a vector program. Because in vector, you're kind of limited to sort of solid colors and linear and circular gradients. And so there's only so much you can do in terms of adding shading, but you can do as crazy as you want with that if you're painting in raster. But that's a whole other, 2-hour lecture on how to do that. Okay, so final other do's and don'ts. So don't use the default ggplot theme. It just doesn't look good. Don't copy plots directly from the RStudio plot window. It's hard to reproduce dimensions this way, and you can't control the resolution. So if you just want to make a quick copy of a preliminary plot, stick it in an email, send it to a collaborator, that's fine. I do that all the time. But for publication purposes, you want to do it the way that I showed earlier. Do use color. It used to be you could never use color in publications. That was because it cost more money to print things in color, but now nobody prints things on paper. It's all PDF. So publishers typically don't charge for having color online. They often encourage it. But do check, though, that your palette's colorblind friendly. Also, that it looks acceptable if it's printed in black and white. So the reason being, this is a service to readers who want to print your paper who only have black and white printers. But also, if the journal does still print to paper, and some of them still do, you won't get charged extra for color printing your figures. They can just convert your figures to grayscale and then print them in black and white. So that's a good thing to check. And pro tip, if your colors are distinguishable in black and white, they're automatically colorblind friendly. So that's good to know. Last thing, do respect copyright laws. So art is all created by somebody. You should give credit where credit is due. Use only images, photographs, etc. that you took or created yourself or that you have permission to use. If you do create your own digital art and put it online, you should know your rights, be somewhat familiar with copyright law, and familiarize yourself with the Digital Millennium Copyright Act, which covers copyright infringement on the internet. Okay, so now on to the more fun part, which is demonstration. So I'm going to demonstrate how to edit and export a figure in Inkscape. I'm going to talk about making drawings and diagrams in Inkscape, including the sort of raster to vector conversion and vector raster conversion. Do a little short bit on diagrams and drawing in PowerPoint, and then if there's time and interest, I'll talk about removing the background from the raster. So I put this down here to remind me, to tell you that when you're working in Vector, and specifically especially in Inkscape, all of the elements that are in your image are referred to as objects. So this square is an object, line is an object, text is an object. The objects consist of what's called a path, which is the outline of the shape or the line that is the line. They can be open paths or closed paths. And the paths have basically two attributes, which are the stroke and the fill. So the stroke is the color of the path itself, so like the line or outline. And the fill is the color inside the stroke, which makes more sense for a closed shape, but you can put a fill on an open shape as well. And the computer will do its best to fill it in. So the locations and the vertices of these paths are determined by what are called nodes. So this square or rectangle has 4 nodes. This squiggly line has some other number of nodes. Usually the nodes aren't visible, but you can move them and edit them in the Inkscape program or the vector editing program. Text is a little bit of a special case, but we'll kind of get to that. I think that's all for the PowerPoint presentation. So can people see this new screen of new document 1 Inkscape?
Yep, we can see it.
Great. So this is the Inkscape program. The newer versions might have the toolbars in slightly different places, but they should all the buttons should be there. So this is kind of what it looks like when you first open it, at least on my computer. The first menu you should be familiar with is this one here that looks like a branch on top of a piece of paper, which is this window, which sometimes appears annoyingly off the screen. Okay, somehow. Oops. Zoom is getting in the way. Okay. Okay, so document properties. So this is where you set the size of the page. So if you don't want A4, you want 8.5 by 11, or you can make it a custom size. This is also where you set the default background colors. So although this page looks white, the default background is actually transparent, which you can see if you select this checkerboard background option, which is how it indicates transparency. If you don't want the background to be transparent, you can change it here and say set it to being white, for example. I'll just leave it as transparent and turn that off. And that's mostly what you need to know here right now. To zoom in and out, you can use the plus and minus keys. That's usually what I do. And let's just make some shapes to have something to play with. So this is our make a rectangle tool. And you can see that you can adjust the size of the shapes either by dragging them, or you can set them specifically up here on this top bar over here. You can also adjust how round the corners are, which is kind of fun. There we go. There's also an ellipse tool. And one thing to note, so this little bar down at the bottom here, which doesn't have anything in it right now, but we'll have something whenever I do something, that little information bar down at the bottom is really, really handy because it tells you kind of what you're doing, what you've selected, and what all of the Control-Alt-Shift keys do for that given tool that you're using. So here it tells you, okay, Control to make square into ratio left, Shift to draw around starting point, stuff like that. So if I want this to be a perfect circle, then you can hold down the Control key and it will do that. Same thing if I go over to the little arrow icon, select and transform objects tool. So that allows you to select things and move them around. And it also tells you in the info bar down at the bottom what it is you've selected. So this is, okay, this is a rectangle in this layer. Here's a circle. This is another rectangle. And you can change the stroke and fill of these objects either by selecting a different color down at the bottom. So you can click on it to set the fill, and then shift click to set the stroke. In this case, the stroke is really skinny and we can't see it. So the other way to set the stroke and fill is to go over to the stroke and fill menu, which you can also get to by clicking on this thing. And here you can set the stroke width. You can make a dash, you can add arrows, change other things about it. You can also change the color here and the color of the fill here, and create other interesting effects if you wanted to. So, for example, we can change this guy. All right, so if I want to edit, oh yeah, other thing, you can, if you click 2 times on an object with the select tool, that brings up the rotation handles. You can rotate them. Forgot about that. Now, if you want to edit the nodes of these shapes, then you would go to the Edit Paths by Nodes tool, which is just below the arrow tool. And then here you can select, say, the corners and move around. Or this, well, that was the curviness. You can make it smaller and do these sort of things. But you'll notice that you can't actually move these in any sort of direction independently of one another, which is because when you make shapes with the rectangle or the ellipse tool or any of these other pre-made shape tools, these are kind of constrained to being rectangles and ellipses. They can't really take on any other shape, which may be what you want and maybe is not what you want. So the way to kind of break that constraint is to select your object and then go to this path menu and click on Object to Path. And it'll look like nothing changed, but you can see that now instead of saying rectangle, it says path with 8 nodes. And so if you go back to our Edit Path by Nodes here, you can see there's now 8 different nodes, and these can all be moved, independently of one another to make this, any shape you want it to be. It doesn't have to be no longer constrained to being a rectangle. You can select multiple nodes and move them at the same time. This got a little messed up, but yeah, so that's how you do that. If you just want to make an arbitrary shape of any shape that's not sort of preformed into something, so that's what this tool here does, this Draw Bezier Curves and Straight Lines tool. And this allows you to kind of create any sort of arbitrary shape. And it takes a little bit of practicing to get used to how this tool works. But basically, if you click once, it creates a sharp corner. And if you click and drag, it creates a curve. And you can kind of create any sort of shape you want with this. If you double click, it'll end the path wherever it is, or you can to kind of create an open path, or you can go back to the beginning and make a closed shape. You can change the fill of the shape, change the stroke, and do whatever you want with it. You can also, a shortcut for getting to the edit nodes is just double click on it, and then you can move them if you want. So the other thing that I will show you is you can create groups of objects. So if you select multiple objects, you can group them together using this group selected objects option, and then you have this group that kind of operates as a unit, so you can make it smaller, you can copy it, do whatever you need to. Note that when you group stuff together and you change the filter, it applies it to everything in that group, which may be what you want and maybe is not what you want. So to select an individual thing inside a group without ungrouping it, you just have to double click on the group and then click a third time, and then drills in one layer and will select, now you can select individual objects inside the group and make changes to them. Once you select something outside the group and select the group again, it'll again select all the objects, and you have to kind of drill back down through it and get to the individual objects again. So hopefully that made sense. check my notes to make sure I've covered everything. All right, I think, oh yeah, text, that's the other thing. So this is a text tool, and you can just click it somewhere and type some text. And you can change the font and the size up here. It's way too small. You can make it bigger, and if you back to the select thing, you could also make it bigger by dragging it. You probably want to hold control down when you're doing that. There's some text. Text also has a stroke and fill, so if you want to change that, you can give it some effects like that. If you want to edit the text again, you can just double click on it and it goes back to the text editor and you can type some more text. Now exceeding the size of my page. So, all right. So now that we have created this lovely drawing here, we can save it. So to save stuff, we just got to go to File, Save As, and then this will give you a variety of different vector file options that you can save your thing as. So PDFs here, as well as EPS and a few other things. So the Inkscape SVG is the kind of the native Inkscape vector format. So if you're planning to edit this in Inkscape again, potentially, you probably want to save it as Inkscape SVG. I'm not going to save this, but you could. If you want to export this as a raster rather than save it as a vector format, you don't go to Save As, you go to Export PNG Image, and that brings up this little menu over here. So you have a few options. So usually, so the export area is what, area is being exported. If you click on Page, it'll export the entire area that's defined by the page, so the box that's your page size. If you select drawing, it'll just kind of draw a box around all of the actual elements that make up the drawing. So, and then just export that. So the drawing will basically go right up to the edge of the file, which maybe you want that, maybe you want a little bit of a transparent border or not. It's up to you. And then you would here, so you can actually set the resolution you want here, which is already 300, but you can make it something else. And that'll set the resolution for the raster. And Inkscape only exports things as PNGs, so you don't really have too many options there. You can change the file name and the directory you want to save it at under here. And when you click Save here, you might think it's actually being saved, but actually it doesn't. It just sets the save location. You have to click, once you set it, you have to click Export, and then that'll actually save the file as a raster to that location. So that's how that works. The Inkscape has a very good online manual, which has some tutorials and some other things, so that's worth checking out. If you plan to use programs more. There's also a pretty big online user community that will answer questions in forums and stuff like that, kind of like ours. So pretty much any question you have about how to do something in Inkscape, you can find answers to somewhere on the internet. Okay, so that's kind of basics of how to use it. So let's go to editing figures. So this is a figure that I made from this project that I'm currently working on. And it's made in ggplot with some faceting. And I've saved this as a PDF, so here it's open in Adobe Reader. And you can tell this is a vector file because if you zoom in, doesn't matter how far you zoom in, it'll never look pixelated. And let's say that I want to make some changes or edits to this figure. So maybe like the 0 and the 1 kind of overlap, and I want them to spread them a little apart some more, but I don't want to make these panels any taller, so we can do that. Another thing that I found is very hard to do in ggplot that's not super hacky is to change the background color of just one of the facet labels. You can also say like make a label for the facets on this side and on the top. So those are all things that we can try and do in our editor. So we'll just open this in Inkscape. I have to name this file. And then you're going to get a bunch of PDF import options, and usually the default options are fine. So you can just go with that. And then it's going to think about it for a while. And up again. So I'm going to change this checkerboard background on so it's a little easier to see. So here's our figure. So if we go in here and we start selecting stuff, so let's say we select these axes labels down here. So I can just look at my little information bar, and this tells me this is a group of 21 objects. So to go inside the group, as I mentioned, you can just double click and then click once again, and now I can select an individual label, and this is now telling me, okay, this is text, Helvetica 9 point. So the same thing kind of for the vertical labels. So this is a group of 5 objects. And if I select the panel, I get this kind of misleading message where it says group of 1 object, which is not just 1 object. So when the files get exported from R, often they have kind of a complicated grouping structure where there can be like groups within groups, and there's like clipping, or sort of like an internal crop that goes on. And you don't really want to go just willy-nilly ungrouping things, so that can kind of screw stuff up. So you often have to drill down through multiple grouping layers until you actually get to the elements that you want, the individual elements you want to edit. So if I were to double click on this and click again, now this is showing the next layer down is a group of 22 objects that's been clipped. So, okay, so if I click again and one more time, now I can select individual bars here. So that's now saying it's a path with 4 nodes in this layer, and it's showing you has a pink stroke, black fill. You can select now this background as a path with 4 nodes, has a white fill and a black stroke. And so now you could, change the fill to something else if you wanted. Same thing for this, say this label up here. So first says group of 1 object, then it says group of 2 objects, and then it says, okay, path with 4 nodes, and I can change the background color. If you don't do that and you try and change the background color, now we've sort of lost our label, which is not good because it's applying it to everything in that group, which you don't want to do. So say if you wanted to move this 0 label, you can double click and then click on it, and then scooch it up, just delete it if you wanted to. You could get rid of some zeros. You can, let's find a different label to do. You can edit the text. So actually, let's use this one. Oops. All right, so this text here, group of 1 object. Now, okay, text, double click on that. Now that brings up the text editor. So we could now change this. Something like, change the text or whatever you want. You can make a copy of this and then, put this, say, as another label on the top or on the side. You can rotate the label if you want it to be vertical, something like that. You could select, say, all of these plots and decide to scoot them over this way and make a little gap there. Now our legend's kind of messed up. We can scoot the legend back over. Or maybe we don't want to do that, so we can make the background bigger and then scoot the legend over. Of course, now the page size is a little smaller than it needs to be. In that case, you can just go back to document properties and then click on resize page to content, and then just clicking on that will resize the page to all of the non-transparent elements in your figure. and do whatever you need to do, and then, or I mean, you could even delete the background if you wanted, and then you can go and save this as another PDF. You can export it. You can do whatever you want to do with it. So that's kind of how you'd edit a figure. All right, next, what's the next demo? Making diagrams and drawings. So yes, so now we're going to do the fish. All right, let's make a new document. All right, so this is a photograph of a filefish, which I picked just because filefish are kind of a fun shape. Well, we can just, I don't know, let's see if it opens. There we go. Here's a little filefish sitting on a label. And let's say we want to, make some vector art from this image here. So what we can do is take our image, this is a JPEG, and drag it into Inkscape, and then it's going to give us, this, do you want to embed it or link it? We're going to end up deleting it in a little bit, so it doesn't really matter what we do. And it's going to be way too huge, so we've got to make it smaller and retain the aspect ratio. Want that on our page. All right, so here's the filefish. Now, my procedure for turning this into a line drawing in Vector is to use this draw Bezier curves tool and basically outline and trace this guy as follows. So you can just start wherever and then draw a line around this little fish. And I'm not going to include the tail at the moment. It takes some practice to do this, so you might have to do it multiple times, and if you screw up, that's okay, because you can always edit the nodes later. And you just go around. And you can close that. And then, okay, now we can do, let's see, we do the tail. There's a separate shape. And I usually close these off, but you don't necessarily have to. We do the dorsal fin and the tail fin. This fish is from that same cruise as the Alma Kojak. There's a lot of cool fish on that one. Okay. So for the eyeball, I can use the circle tool for that. And you clearly need to change the stroke and fill options on this guy. Let's go something smaller and there. Yeah, let's forget the little tiny pectoral fin. I'm doing this kind of quickly because we need to watch me do this all day. Right, here's our pupil. All right, so that's most of all the outlines. So now we can, let's just take this photo and move it out of the way. Oops, and let's select all these. Let's give them all white white fills. Stroke width. Let's do that later. Okay, so that's a start. As you might notice, that fill and fins have kind of ended up on top of the body, which we don't want. So we can select all those and send them to the bottom. And we can also, these lines are kind of skinny, so we can adjust those. We probably need to move some of these nodes too, like these ones didn't quite line up with the tail. Yeah, make some adjustments as needed. So we can, let's see, let's select all these. Let's make these lines thicker. I guess that's okay. Eyeball. A little thicker too. The pupil, I think we want to fill that one in black instead of white. And it's not big enough. Yeah. 2, 1. These. Anyway, till you find something that looks good. So then, okay, so that's not too bad. We can try and edit this a little more to make it look better, but that's, you know, the basics of how you create one of these. And we can edit the nodes. So these little handles here, these are just the handles that determine what angle the line exits from the nodes. You can adjust those. There's a whole bunch of options up here in terms of editing nodes and a path. Okay. Right, so there we go. Now we could delete our photo and say resize the page to the content and to kind of box this guy in some more. So I can kind of show you how to do that. So maybe we want to, okay, it keeps getting in the way. Stop it. Right. Here we go. So here it's, well, resize to drawing our selection. Here I've selected it, so it'll automatically do that. And if I wanted to do like a little bit of a border around this, I could do that. And then it'll bring it in around this guy. So there's our black and white fish. So if you wanted to color this guy in, you know, that's just a matter of changing the fill color. And one kind of handy thing about keeping the picture up here is that you can use this select or pick color from image to actually select a color in this picture of a file fish and set that to be the fill for the shape. You may have to do that a few times because there's a lot of different greens in that image. We could, you know, set the fin color, something else from the image that's, you know, reasonably accurate. You can, you know, add some yellow lines on the tail to show this kind of these rays here. You can get really crazy with color gradients if you want. That's kind of a whole other adventure, but can be kind of fun. Oops, not that one. Yellow is nice. Or eyes is a nice yellow color. So you can get as involved as you want with that in terms of coloring it. And then now you've got color fish. Okay, so that's
Tanya,
the fish demo. Yes.
Can I just ask, you did some shade of colors. Is it way more complicated to do that than just having one color per element? Another element, sub-element or something?
So it's definitely easier to do solid colors. So the way that you do gradients is there's so in the stroke and fill option, so there's flat color and then there's also linear gradient, radial gradient. I don't really know what these other kinds of gradients are, but you can select one of those and then it takes a little bit of editing them is a little bit tricky. So you have to, well, let's just do a linear one because that's easier to deal with. So one end will be one color and another end will be another color. You can control where those colors go. Oops, For whatever reason, it defaults to one end being transparent. So you want to change that to something else. I can just pick another image, another color here. And we can pick the other end and pick a different color from the image, say that one. Hopefully that gives you slightly more contrast. I think you can add another stop on the color gradient. Maybe this is like a lighter green. I don't know. So you can see how it gives you a little bit more depth. Makes it look a little more realistic. So that's basically making the fill a gradient, and then the gradient just has different stops on it that are assigned different colors, and then the computer just sort of interpolates between them. So that's how you do the gradients. Does that make sense?
Thanks. Yeah, that's awesome.
Okay, so my third demo, so that one, let's make yet another new file. So this is another way you can go from a raster image to a vector image. So this is a little drawing of a krill that I made. So I drew this on paper, oops, and I scanned it, and I cleaned it up a little bit in a raster program, and then I say this is a PNG file. So I'm doing this background. So well, what I'm showing you, it'll work even if the background isn't transparent. It just needs to be a black and white, or yeah, black and white image. So this is clearly raster. If you zoom in, it's going to get blurry. And one way that you can convert something like this, which is like a simple line drawing, to a vector image is to select it, and then you can go to Path Trace Bitmap, and it brings up this little box here, and there's a bunch of different options. I find that the default works pretty well just for black and white image, but if you can screw around with them if it's not working for some reason. You just click OK, and it looks like nothing happens, but actually the software has gone and basically traced this image, at least the black parts of it anyways. And this is in vector here, this little shape here. So it's, it does a pretty good job at getting the shape right. So now you could, delete that thing if you wanted, and now we have this vector krill. Of course, you'll notice that there's no white now in the middle, and I think there are a few different ways to go about filling it in, but the way that I've found to be the easiest is to just draw a square and make it white. Get rid of the stroke, just make a white box basically. And then I want to send this to the bottom. Select the black outline image. Oh, well, why am I doing this? So you might think, oh, well, I just got to set the fill on this thing, but the fill is actually the shape itself has a stroke and a fill. So that, may or may not, if you set the stroke and fill, you're going to get something like this. It's not really going to be maybe it's what you want to go for, maybe it's not, but that's an effect you like. But essentially you need to, create new shapes in the center that you can edit independently. Okay, what am I doing here? Want black fill, no stroke. Okay, there we go. All right, so we make this white box, put the shape on top of it. Then you hit Control D to make a duplicate of the krill exactly where it is. You select both the krill duplicate and the white box, and then you go to Path Division. And what this basically does is it divides the white up along all of the lines that are given by the krill object. So we can select this outside part and delete it. There will also be this sort of white, snapping off for a second, white outline that you don't necessarily want there. So we can use Alt-click to select underneath the black and delete that. So now it's just the center part. Then you can select all, deselect the black outline, and then group it. So now you have completely sort of independent but editable sort of exterior and interior parts of this image. So that is pretty handy, and now you can sort of edit these colors independently. We could, you know, decide we want that this one needs a black eyeball to give it another eye right there. So that's another way you can do this. So there's the krill. Okay, next, how to do some of this in PowerPoint. So let's go back to PowerPoint. This is the end of my presentation. So here is the same filefish image that we had earlier. So I've just now put it into PowerPoint. So PowerPoint has this draw, you know, curve tool, which actually is very similar to the Draw Bezier curves tool in Inkscape. It operates a little bit differently, like you kind of can click anywhere and it just creates curves, like there's no sharp corners, which is kind of annoying, and it takes some practice to use this too, but you can more or less do the same thing in PowerPoint as I was just showing you in Inkscape. So just kind of tracing around this guy. I don't even know where I started. Somewhere over here. We can change the stroke, which here is just called shape outline, and you know, fill it in, do whatever you need to do. Exact same concept. You can edit the nodes directly if you go over to edit shape, edit points. Now you can actually move the nodes around, change, you know, they'll have little handles you can change, edit as well. And usually the first pass doesn't look very good, so you're probably gonna have to edit the nodes when you do this. So, you know, procedure is exactly the same here as in Inkscape. Here's just some examples of some other shapes or drawings I've made in PowerPoint. So let's do this one first. This little uni sushi thing that I made. This is grouped. So if we ungroup this, you can see that this is actually just like an ellipse, another ellipse, two triangles, an arbitrary, you know, shape that I made, and then these two objects, which consist of, you know, one circle and this other arbitrary shape that are just layered on top of each other. This shape has what's called an inner shadow applied to it, so that's just shape effects, shadow, this one here. That gives it that effect. So you just, you know, assemble all those together, and that's what creates that image. These also have some inner shadows applied to them, so that's pretty cool. The sea urchin, likewise, is a PowerPoint shape, so let's just ungroup that. It contains a lot more elements, but this is really just a triangle with a gradient applied to it, you know, and rotated and made a bunch of different sizes. The, you know, background is just an arbitrary shape that I drew with some little bit of shadow things and gradients applied to it. So that's sea urchin. See my cat again. So, all right, where am I guess I think that's most of what I wanted to cover. So if people have questions, I guess we can go to questions now. And if there's interest in the removing background from a raster topic, I can go over that. So I'll stop talking now and see what you have to say.
Thanks, Tanya. This is awesome. Does anybody have questions? You can put them in the chat or just speak up.
I've got a question. I've used Adobe Illustrator, and in Illustrator you have the option of doing, you just put in a JPEG image, you press a button, and it traces all of the lines and shapes, and it gives you a vector image, no, a raster image. What were the two options? But anyway, it makes it into the better shape that you can, .ai shape, but that's just from an image itself. I'm wondering if Inkscape has something similar to that, or if they're just not there yet.
So which one of these is? So the trace bitmap option, it does have a few other settings. So like having multiple colors, you can, there's a few other things. I haven't played around with it too much with like full color images. Yeah, there might be some other things you can play with. So, but this is where you would do that. And I don't think the software is quite as advanced perhaps as in Illustrator, but it works well enough for simple colors.
Thank you so much, Tanya. This is a great presentation.
Oh, you're welcome.
Hi, I have a question. My name is Vinicius. Thank you for the presentation. It was really great. So you mentioned that in R, you would plot things in ggplot, and then I'm guessing export them as PDF and then import them into Inkscape. Is there something about ggplot that makes it more conducive to editing outside of the software, or outside of R or Python or something like that? Or are there other plotting libraries that would work just as well?
Oh, the base plotting libraries you can edit them just the same. So it doesn't really matter which plotting software you or which plotting package you use.
Okay, great. Thank you.
I see two questions in the chat. One, I think, is regarding Core and where the recording will be available. And we can email that and put it on our Twitter, or you can contact us if you'd like to get the whole thing. But someone else wants to know if there's a magic wand type tool in Inkspace.
So there is in GIMP, and that's more of a kind of a raster type tool. Since usually what that does is it's selecting pixels that are all of the same color value, which is sort of irrelevant in vector because there are no pixels. So there might be an option to like select all objects that have the same fill color or something like that, and then sort of change them simultaneously. I forget what it is exactly, but you can probably find that somewhere online. So I guess that's all I am aware of.
I have another question. If you had kind of one pet peeve of what people do in their figures that make them unnecessarily hard to interpret, what would that be?
Well, I guess this is mostly directed at mathematicians, which they have a tendency to use variables as axis labels, which I find very annoying because it's like I gotta look up in the figure what that variable is, rather than just using sort of a plain text axis label. But ecologists generally don't do that so much. In presentations, it's making the labels too small that you can't read them. Or using the default ggplot theme. So, which, it's at least puts some effort into it. So, yeah, I guess I'll have to think about what else. Yeah, those are the main ones.
Those are good tips. Thanks.
Hey Tanya, it's Arena. I have a question about colors. So on the, I know in the fill panel you have like the RGB option. What other options are there in terms of like, because I know sometimes a publisher will require specific color, what's it called? You know what I'm talking about? Yeah, like
Yeah.
RGB and
So
all that.
here, so these are just different ways to specify the colors. So if you want to, you know, I find RGB is kind of hard to set a color using it. I often use the hue saturation value, which is a little more intuitive. So, you know, what is the color, how intense is it, and then how dark or light is it? And kind of interestingly, when you convert to grayscale, basically you set the saturation to 0, hue becomes irrelevant, and the only difference is value. So, and transparency, you can hit it as well. These are just like different ways of specifying what color you want. The RGB versus CMYK has to do with the way that, I believe it's the way that the colors are encoded in the raster. And sometimes publishers, especially ones that print stuff, will want them in CMYK because that's like the 4 layers of the printer that get printed because of the colors that the printer prints out. I haven't had to deal with that so much because like no one prints anything on paper anymore, but I think you can use the raster software to change the color encoding to CMYK.
So if you do need it to be in one versus the other, you should just stick to that in Inkscape. Like if you know it needs to be in RGB, you should select your colors in RGB.
No, so this, which of these options to use is not setting the color encoding. This is just like different ways to pick a color. So, you know, changing this doesn't really change how what the color is. It's just how the color can be specified by the user. So, and it's just sort of what method you like and that you're familiar with, and that makes the most sense to you. So the color, when you export it and save it, I don't know what it uses by default. Probably RGB. If it needs to be CMYK, you're gonna have to like open it in a raster program, change it, and then resave it probably.
Got it. That's helpful. Thank you.
I think there is somewhere you can supply the hex code, but I don't remember what it is. It might just be one of these down here. Yeah, I think it's this one.
Tanya, looks like we have another question in the chat. Somebody's asking, do you have a suggestion of how to choose a color scheme quickly that actually looks nice, and how to find the colors that are colorblind legible?
That's good. I can't see the chat, so reading the questions is good. There's, what is the name of that? There's some websites that are like color palette generating websites that are really cool for like picking colors that go nicely together, if you're into that. I usually just kind of, well, sometimes it's just a little bit arbitrary and what I think looks nice. You can find colorblind friendly palettes online, and then there's some sort of color palettes in R that are known to work well for that. I think the Viridis gradient, I think, is supposed to be really good for color blindness and black and white printing. So if you think that looks good for your figure, you can do that. If in doubt, like the best, which is kind of an advantage of the HSV hue saturation value designation, is the sort of value level will determine how bright or dark it is when it's converted to black and white. So these are clear, this is a much lighter color than this one. Black, of course, would be completely dark. You can also just like in PowerPoint, for example, you can try changing the, I forget what it is. to, yeah, changing it to grayscale. And that's kind of a quick way to see how things look. If you happen to have a colorblind friend, I happen to know some, you can ask them to take a look at it. My PhD advisor is colorblind, so that's useful. And there's plenty of resources out there you can use. I think there's some websites that allow you to upload images and see how it looks like in different types of colorblindness. So that's kind of a long answer. I hope that answers most of your question.
I have a follow-up question on the color scheme then. If you find something amazing online, which I know they exist, and if you want to use it in Inkscape, would an easy way to do that be to kind of import a picture of it and then use that eyedropper tool to directly match to those colors? Or is there some fancier way to do that?
You could do that. So, or you could, if you can often get the hex codes from those palettes, and I believe it just goes right here. I think, well, there'll be 6 digits, and then the last 2 are the transparency indicators. So that's where you can often just get those out of the palette. Will sort of generate them, and you can just paste them in here, and that'll be the color that should match exactly.
Cool, thank you.
Oh yeah, so it's the red, the green, the blue, and the alpha. So that's what that is. So in case anyone's curious, this is the Jack image. So this one, the fill of the body of the fish is this sort of complicated gradient that I created. There's also these sort of other gradients that I've used throughout here that show up in this gradient list. We can also put a gradient on the stroke, which is kind of fun. Yes.
I wanted to ask you what your tips are for scanning your drawings.
I will draw them in pen, and that tends to work better than leaving them in pencil and try to erase all the pencil. And then I'll scan them just with a scanner and at a reasonable resolution. And then I would typically open them in Photoshop and then just kind of clean up or adjust the contrast and the sort of white and dark points so that it's, it kind of gets rid of most of the intermediate gray colors. And it's really just a black and white image. I'll try and also clean up little stray bits of dust or stray marks kind of on the page if those get scanned. And then I'll use that magic wand tool to select the background and delete it. Mm-hmm. So that's sort of my process for dealing with the scans. And then from there, you can either take it over into Inkscape or I can color it in Photoshop. So.
Okay. Cool. Thank you.
Mm-hmm.
Well, thank you, Tanya. This is awesome. I'm excited to, dive into Inkscape some more now that you've told us all the secrets. Yeah. If there's any more questions, we still have a little bit more time.
I guess one thing I will say is that you can do most of the stuff in Inkscape in PowerPoint, as I was mentioning, and especially if you're collaborating with folks on a diagram or something where other people need to be able to edit it directly. Sometimes it can be more advantageous to make it in PowerPoint because it's more, most people have PowerPoint installed and they can open it and they can, you know, move things around and change things more easily than in Inkscape because not everybody, you know, knows about it, knows how to use it. So that's, I'll do that sometimes depending on what project I'm working on. So that's just another thing I wanted to point out. Okay, that's it. And yes, definitely if you're tracing stuff like we're doing, you know, make sure it's an image you can use. Okay, how do I get out of here?
Well, yeah, I guess if there's not any more questions, then we could probably reach our end. Yeah, thanks, Tanya. This is awesome and super helpful.
Yeah, you're welcome. Feel free to, you know, if you have other questions, just let me know.
Thank you.
Sounds good.
Thank you. This was all super useful.
Thank you.
And we'll make the recording available. We'll figure that out later today and get it out to everybody.
I did put our email address and our Twitter handle in the chat, so you can either email us directly or check Twitter at some point today or tomorrow, and we should have that there.